welcome to the next tutorial classes. So, we will continue the in the scattering matrix tutorial. So, we will do the next problem. So, next problem is consider the two port network with individual scattering matrix SA and SB. So, here two port networks having individual scattering matrix SA and SB, so that the overall S21. So, we have to find out the overall S21 parameter of the cascade of these networks is given by S21 equal to S21A, S21B 1 minus S22A into S11B. So, here it is a two port network for that like this. So, it is a two port network. First is like this, having SA, we can denote like this. This is SA. So, here is one S port network and another S port network is like this. It is cascaded and it is parameter of this is known to us. So, here it is port 1 and this is port 2. Here because this is known and this is a two port network. So, we can write SA, it is defined as S11A, S12A, S21A, S22A. So, this is the meaning of SA. Similarly, for SB, equal to S11B, S12B, S21B, S22B. So, this is the SA and SB, it is known to us. So, for this port 1, so it is here port 1, here it is port 2, and we can assume that we can take some this side is A and this reflected part is B, and here we can see like this is V1 plus and here reflected wave is V1 minus, and here from port 2 it is incoming wave, that is V2 plus and reflected wave is V2 minus. Here A and B, we can see that A is reflected wave for this for first network. This wave A is reflected wave, that is means it is going reflecting from the A network, but incoming for the second network, this A parameter, but B that is incoming for port 1, but outgoing for port this second network. So, for the first one we can write like this. So, this is the reflected one from like for the this first network, V1 minus is the first reflection and A is the second reflection. So, for that we can write V1 minus A equal to this matrix, we can write as SA into and V1 plus, that is first incoming and B is the second incoming. So, that is V1 plus and B, we can write like this, and here SA is the 2 cross 2, and also for the second part, this A is the first incoming for the second part and B is the first reflection for the from the first port, B is the first reflection and V2 minus is the second reflection. So, B into V2 minus equal to SB, and A is the first incoming and V2 plus is the second incoming. So, here it will be A and V2 plus. So, from these two equations and for the total, if someone will write the total S parameter matrix. So, it will be written like, means for the total we can assume that this is one system. These two systems are cascaded, but we can assume that this is one system and this has overall S parameter matrix is like this S11, S22, S12 and S21. So, for that we can, for the total we can write V1 minus V2 minus equal to this S V1 plus V2 plus. So, here we can see for the total overall system V1 minus is the reflection, first reflection, and V2 minus is the second reflection. Similarly, V1 plus is the first incoming and V2 plus is the second incoming. So, it can be written like this. So, we have to find out the S21. So, S21 we know, S21 definition will be same. So, here S will be, means S means it can be, it is like this S11, S12, S21, S22. So, this is the S matrix, overall S matrix. So, S21 will be V2 minus divided with V1 plus when V2 plus equal to 0. So, V2 plus equal to 0, that means it is terminated with match load. So, if V2 plus equal to 0, so in this system, if V2 plus will be equal to 0, then in that case B will be B equal to S11 B into A. So, we can write for V2 plus equal to 0, B equal to S11 B into A, and also V2 minus equal to S21 B into A. So, it can be written from the second part, and A will be equal to S21 A will be equal to S21 A V1 plus S22 B A into B. So, this is coming from here, A equal to this S A can be written like this. So, S21 A into V1 plus and S22 A into B, S22 A into B. So, B we can written, B have written S11 B into A, we can substitute here. So, B we can substitute equal to S21 A V1 plus S22 A, and B will be S11 B into A. Then V2 minus will be V2 minus is S21 B into A. So, we already written S21 B into A into V2 minus into V2 minus divided with S21 B. After this, we can take the common V2 minus, and this will come, this S21 B will cancel out, and this will come V2 minus 1 minus S22 A S11 B equal to S21 B into S21 A into V1 plus. From this we can write V2 minus divided with V1 plus equal to this S21 B into S21 A divided with 1 minus S22 B S22 A into S11 B. So, this is the S21 when V2 plus equal to 0. So, this is the S21. So, yeah. So, we can go to the next problem. So, next problem is a 4-port network. Now, in the previously we have done for the 2-port network. So, it is a question on the 4-port network has the scattering matrix shown below. So, first is this network lossless? Is this network reciprocal? What is the return loss at port 1 when all other ports are terminated with match load? D part is what is the insertion loss and phase delay between 2 and 4 when all other ports are terminated with match load? Means 2 and 4 means insertion loss and phase delay between port 2 and 4 when all other ports are terminated with match load. Next part is what is the reflection coefficient seen at port 1 if a short circuit is placed at terminal plane of port 3. Means short circuit is placed at port 3 and all other ports are terminated with match load. So, we will see the one by one. So, first is this network is lossless. So, for the lossless we know means it should satisfy the unitary condition. So, to satisfy that we have to add all this S11 whole square plus S12 whole square plus S13 whole square plus S14 whole square. So, that we can add, and if it will equal to 1 then it will satisfy the unitary and it will be lossless. So, S11 whole square plus S12 whole square plus S13. So, this is for the 4-port network. S13 whole square plus mod of S14 whole square equal to, so this will come 0.1 whole square plus 0.8 whole square plus 0.3 whole square, and this will come 0.74. So, this is not equal to 1. So, we can say that this is not a lossless network. So, if this network is means symmetric, then next question is means is this network reciprocal, because we can see that means this is the symmetrical network, this is the symmetrical, then we can see that this is the reciprocal. What is the return loss at port 1 when all other ports are terminated with match load? So, first we have to see that how this means 4-port networks are looking. So, for the 4-port network we can write like some system is there and it has port 1 like this, port 1, port 2, port 3, port 4. So, if it is port 1, port 2, port 3, port 4. So, port 1, so at port 1 this will be V1 plus and this reflected from port 1 V1 minus. It is incoming wave at port 2 V2 plus reflected from port 2 V2 minus. Incoming at port 3 that will be V3 plus and reflected from port 3 that will be V3 minus. Incoming at port 4 it is V4 plus and reflected from port 4 that is V4 minus. So, like this for the 4 port network we can write the voltages that incoming and outgoing. So, in the matrix term we can write like this V1 minus, V2 minus, V3 minus, V4 minus. So, this is like this 4 cross 1 matrix and S11, S12, S13, S14, S21, S22, S23, S24, S31, S32, S33, S34, S41, S41, so it should be S41, S42, S43. So, we are at the 4th row and 3rd column, S44. So, this will be matrix and here it will be V1 plus, V2 plus, V3 plus, V4 plus. For the 4 port network it can be written like this. From this we can see that so in the equation format it can be also written V1 minus equal to S11 into V1 plus in S12 into V2 plus. So I am writing 1. So, a V1 minus equal to S11 V1 plus S12 V2 plus. So, it can be written in the forms of equation like this S13 V3 plus S14 into V4 plus. So, in the question it is written what is the return loss at port 1 when all other ports are terminated with match load. So, we can see that S11 means reflection at port 1, reflection at port 1 means return loss at port 1. So, we have to find out first S11. So, S11 it can be defined as S11 equal to V1 minus divided with V1 plus when all this will equal to 0, V2 plus, V3 plus, V4 plus, this will equal to 0. That means there will be all will be terminated with match load. In that case this V2 plus, V3 plus, V4 plus will equal to 0 because there will be no reflection from the load. So, for that case we have available that S matrix. So, for that case this will equal to 0.190 degree. So, from the question it will equal to 0.190 degree. Return loss can be find, we can return loss equal to minus of 20 and this will equal to gamma, mod of gamma, that will equal to minus of 20 log of 0.1, that will equal to 20 dB. So, this is the answer for the third part. Next part is, what is the insertion loss and phase delay between port 2 and 4 when all other ports are terminated with match load. So, between insertion loss between 2 and 4 when other ports are terminated with match load. So, we have to find out S42. So, S42 means, so we can compare with our matrix. S42 is this part, S42. S42 between port 2 and 4, S42, that means V4 minus divided with V2 plus, S42 when all other ports are match equal to V4, first is the reflection V4 minus divided with V2 plus, with all the other ports are terminated with match load, that means V1 plus equal to 0, that V3 plus equal to 0. So, for that this condition will come. So, all are terminated with match load, that means this part 0.4 45 degree will be the 0.4 45 degree will be the S42, that will be the S42, and from this we will get phase delay 45 degree and return loss, that insertion loss, because return loss is from the same port, but insertion loss is when it is going from, it is coming from the port 2 and going means V4 minus, that is going outside from port 4. So, it is entering at port 2 means port 2 it is entering port 2, that is V2 plus, and it is going to the network, and then it is V4 minus, it is if it is port 4. So, that is V4 minus. So, it is insertion loss. So, that is insertion loss will be minus of 20 log of mod of S42 equal to minus 20 log of 0.4. So, that will give 8 dB. So, insertion loss between port means port 2 to port 4 will be 8 dB. So, and phase delay will be 45 degree, that we know from the phase delay equal to 45 degree. For the next part, it is what is the reflection coefficient seen at port 1, means we have to find out S11 when short circuit is placed at terminal, means short circuit is placed at port 3 and all other ports are terminated with match load. So, port 3 will be short circuit and other port will be match, and we have to find out the S11. So, for this other means port 3 terminated with short circuit, other ports are is match, that means V2 plus equal to V4 plus equal to 0. Since port 3 is short circuit, that means V3 plus equal to minus of V3 minus, and from the equation of V1 minus, from this expression V2 plus is 0, V4 plus is 0 and V3 plus is minus of V3 minus. So, we can write the V1 minus as, we can write V1 minus equal to S11 V1 plus S13 V3 plus, and V 3 plus is minus of V 3 minus. So, it can be written as S 11 V 1 plus minus S 13 V 3 minus, and V 3 minus we know V 3 minus equal to S 31 into V 1 plus. So, we know S 31 equal to V 3 minus divided with V 1 plus. So, we can substitute this V 3 minus here, and we will get V 1 minus equal to in terms of V 1 plus, and we can take the common V 1 plus. So, let us do. So, V 1 minus equal to S 11 V 1 plus minus, and V 3 minus substituting, and S 13 into S 31 V 1 plus. We can take the V 1 plus common from the right side, and taking the left side, and V 1 minus divided with V 1 plus equal to S 11 minus S 13 S 31. So, this is the S 11, this is the S 11 when port 3 short circuit and port 2 and port 4 are that is matched. So, we can substitute S 11 is 0.1 J, that is 90 degree, minus 0.3 minus 45 degree, 0.3 minus 45 degree, this is minus 45 degree. So, this, and after this will come 0.1 J plus 0.9 J, and this will come 0.19 J, and this can be written like, because J is 90 degree. So, this can be written as 0.19 90 degree. So, this is the answer for the last part, when this is the reflection coefficient seen at port 1 when port 3 is short circuit and other ports are terminated with match load. So, this will be the answer for the last part. Thank you.